Graph each set of numbers on a number line. Order the numbers from least to greatest. Today we're getting into inequalities, your less than, greater than, less than equal to, greater than or equal to. Get excited. So we're going to put these on a number line, and then we'll put them in order from least to greatest. We're going to put them all on the same number line. I see the smallest number I have is -10. The largest number I have looks like it's 7. So we just have to make sure we include those. So I'm going to put 0 in the middle, -1, 2, 3, 4, 5. I'm just going to label every 5. -10, 1, 2, 3, 4, 5, 8, 9, 10. All right, so I'll do number 1 in red. So -3 is here. We have +7, and -9 is over here. So remember, it's always our smallest on the left on the number line. So it'd be -9, -3, and +7. You should be able to do this in theory without a number line. Again, we're just adding a tool to the tool belt. Number 2, we have -2, -10, and -8. So let's say -10 is the smallest, -8, and then -2 is the greatest. It's the greatest. We got a 0. We got 3, and we've got -5. So -5 is the smallest, 0, and 3. Great. All right, I want to show you, I want to just give you like a quick cheat sheet that you can reference back to about the dots, because here's what you're going to come up with. So last time you came up with like x equals 10, and it was just one number, right? The only solution is x equals 10. Today we're going to come up with stuff like x is less than 4. So any number less than 4 would be a correct solution. So that includes 3. That includes -1000. That includes 3.9941628735012, right? Anything less than 4 is included. It's infinite. There's no limit to the answers. So you can't possibly list all the answers. So that's why you list it with an inequality, because that does show every possible solution. So when we do graph something like x is less than 4, we're going to show it on a number line. And it's going to look like this. And it shades to the left because this shows it's any number to the left of 4. Any number less than 4 is a solution. So you're going to have a dot, and you're going to be shading one of the ways. So I try to tell you the way that I can remember it the easiest. So dots, it's going to be an open dot if it's less than or greater than. It's going to be a filled in dot if you have the or equal to's. And the reason you have an open dot if it's less than or greater than is because that solution, that number is not part of the solution. And I'll show you kind of what that means when we actually solve one of these. It's going to be a solid dot if that number is included in solution. So the way I always have to try to remember that is it's going to be if they're using the extra ink to write the or equal to, then you got to use your extra ink to fill in your dot. Huh? All right. So here's the rules as far as shading. So if the letter is first, if the variable is first, and again, you'll see what we mean here in a little bit. Then less than or equal to you shade left. Greater than or equal to, you shade right. So it's interesting because as long as the variable's first, you kind of shade the way the arrow points. Less than points to the left, so you shade to the left. Same with less than or equal to. And then greater than or equal to, the arrows point to the right, so you shade to the right. So there's a song that you'll hear me sing about 50 times, and it goes a little something like this. If the letter is first, then follow the arrow. If the letter is second, then don't. And if the letter is third, then the letter's not going to be third. It's either first or second. So if the letter's first, follow the arrow. If the letter's second, you just go the opposite way that it points. Let's get after it. You'll see what I mean here once we get going on some of this. Graph the solutions of each inequality on a number line. Now you can make your number lines as fancy as you'd like. You can make them include 75 numbers. All I care about is the solution. So to me, you can just have your number line with a 3 on it. Now as far as the dot, so you could look up there, but let's kind of remember what the dot means. It's saying, is this number part of the solution? So can I say that 3 is less than 3? No, it's not less than 3, it is 3. So that's why it gets the open dot. It is not included in the solution. Now, which numbers on the number line are less than 3? It's the numbers to the left of it. Or you can remember, if the letter is first, then follow the arrow. It's pointing left, so shade left. But if you are a person that likes to have more numbers on your number line, you certainly can put as many as you like. And then it might be easier for you to think like, oh, well, which ones are less than 3? 2 is less than 3. Okay, that works. All right, here we have x is greater than -1. Is -1 part of that solution? Can you say that -1 is greater than -1? No. So you get an open dot. The letter's first, so let's follow the arrow. It points to the right, so shade to the right. It's just that easy, folks. It's just that easy. All right, let's try out some more. Oh, a is less than or equal to -2. -2. Now this is our first one with the or equal to's. So can you say that -2 is less than or equal to -2? Yes, that's true. So anytime it's or equal to, you're going to have that solid dot. And less than would be to the left. Or, remember, the letter's first, so follow the arrow. Points left, so we'll shade left. Oh boy. -6 is less than or equal to g. So we care about -6. Can you say that -6 is less than or equal to -6? Yes, that's true. If it helps, you can always rewrite the inequality with the variable first. If you had -6 is less than or equal to g, that can be rewritten as g is greater than or equal to -6. And then you might be having an easier time saying, oh, well, the letter's first now, so I'll follow the arrow. It's pointing to the right. And that's correct. But if you just remember the old song, if the letter is first, then follow the arrow. If the letter is second, then don't. It's pointing left originally, so shade the opposite way. Just because the letter's second. Or rewrite it where the variable is first, and then follow the arrow. So I have some that I'd like you to try. To put them on a number line. Oh my goodness. Oh my goodness, seriously. It's just one of them days. You know what I mean? There's 4 of them. Graph them, try it out, pause it, and try it, and I'll do them right now. All right, hold open dot, the letters first, so follow the arrow. Open dot, the letters second, so we're going to go the opposite way. It's pointing right, so we'll shade left. Or you can rewrite that as t is less than 4. Solid dot, because it's the or equal to, the letters first, so I'll follow the arrow. And solid dot, because it's or equal to, the letters second, so if you want, rewrite it the opposite way, and then follow the arrow, or just look at the original one, know that the letter's second, so we go the opposite way. So this will be shaded to the left. Write the inequalities shown in each graph. Ooh, this is fun. This is really fun. Wow. So let's just use x and the number that has a dot, 0. This is basically a fill-in-the-blank question. Is it less than, greater than, less than or equal to, greater than or equal to? Well, it's an open dot, so it's got to either be less than or greater than, and it's shaded to the right, so that would be greater than. So x is greater than 0. X, -1. It's a solid dot, so I know it's got to be the or equal to, and it's shaded left, so that would be less than or equal to. I think I got one for you to try right here. Yeah, try this out. Write an inequality for the graph below. So pause it, try it, and then check back in. It's a solid dot, so it's the or equal to, and it's shaded right, so greater than or equal to. Yeah, real world problem. Now you're going to see some keywords just like we did with the variable expressions like sum, product, all that stuff. Similar stuff with inequality. So at most, you'll see that a lot. That means no more than, right? So at most would be less than or equal to. Oh yeah, it says that right there. At least is the one you probably see. Yeah, you see these two the most. So at least means no less than, and so you would say greater than or equal to. If I said I'm going to give you at least 20 plant dollars, and I give you 100, that's cool. If I give you 20, that's cool. That's still at least 20, but I can't give you 5. You'd be like, you said at least 20. Okay. Food can be labeled low sodium only if it meets the requirement established by the federal government. Use the table to write an inequality for this requirement. Low sodium. All right, let's write them for all of them. I think it just said for low sodium, but let's do all of them. Sodium free has less than 5 milligrams per serving. So less than, let's say x is less than 5. Very low sodium would be at most 35 milligrams. So x 35, at most it could be 35, but it has to be less than or equal to 35. And then low sodium food has at most 140 milligrams. So let's say x is less than or equal to 140. Use the table in example 3. A certain food is labeled sodium free. Write an inequality for n the number of milligrams. I think we did that. Yeah, we already did that. So we're all good. Let's get graphing some inequalities, huh? Let's get graphing.